Hello everyone. In today's lecture, we are going to see what is universal law of gravitation and what is the force of gravitation acting between any two objects in this universe. Now, why do we call this universal law of gravitation? Because it is valid for any object in this universe, and it is same thing for each and every object, whether it is terrestrial or celestial, right? So, let us see what is universal law of gravitation. Now, according to this law of gravitation, it states that the force between any two bodies would be attractive in nature, and that force is directly proportional to the product of masses of those two bodies and inversely proportional to the square of the distance between them. Let us see what is that. Okay, so statement the statement of this law is nothing but that the force acting or existing between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them, right? So, this is the statement: the force acting or existing between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them, right? So, mathematically, what do we write? So, mathematically, suppose there are two bodies, body A and body B. Suppose mass of body A is m1, mass of body 2 is m2, okay, and they are separated from center to center of each masses or each bodies. Center to center distance is r. Now, why I am saying center to center? This will be taught to you in detail in center of mass concept, okay, which will be taught to you later. But always remember that the distance is considered from center to center. So, there are two bodies, body A and body B, masses m1, m2, separated by distance r from center to center. So, according to the statement of universal law of gravitation, the force of gravity or the attractive force or force of attraction between any two bodies, okay, for this particular example, the force would be directly proportional to the product of their masses. Also, the force is inversely proportional to the square of the distance between them, right? So, if we combine these two things, the two proportionalities over here, what do we get? F is proportional to m1 m2 upon r square. F is proportional to m1 m2 upon r square, right? So, this is the force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, what if we need to find out the exact magnitude of the force or exact magnitude of the attractive force existing between any two bodies of masses m1 and m2 and separated by distance r? Let us see that, okay. Now, as we have already seen, that is the force or the attractive force or the gravitational force between two bodies of masses m1 and m2 separated by distance r is directly proportional to m1 m2 upon r square, right. So, exact value of this attractive force or the gravitational force acting between the two bodies or existing between the two bodies, we say, okay. When we say existing, means body A will be exerting force, that is F, on body B, as well as body B will be exerting the same amount of force on body A also. That is why we call it existing. The force is existing between any two bodies, right. So, to be exact about this particular force, we write one proportionally constant F equals to G into m1 m2 upon r square. This g over here, as you can see here, g is nothing but proportionally constant, and this proportionally constant is also called as gravitational constant or universal gravitational constant, and its value is given as 6.67 into 10 to the power minus 11 Newton meter square per kg square, right. So this is the value. You just need to remember this. I'll let you know how we derive this value, okay. But before that, let me tell you what is G. That is proportionally constant, okay, also called as universal gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square, okay. Now, so this is the attractive force existing between the two bodies, right, any two bodies, either terrestrial or celestial, okay. Now, if this is the force existing between the two bodies and G is the gravitational constant, over here G or the SI unit of G, as you have already seen, it is Newton meter square per kg square, okay. What is G exactly? G, if both the masses of the body are equal, that is 1 kg, and they are separated by 1 meter distance, okay, 1 meter distance, and the force comes out to be F equals to G 1 into 1 upon 1 square, isn't it? So F equals to G. So universal gravitational constant is nothing but the force of gravity or attractive force existing between two bodies of unit masses and separated by unit distance. I hope that is clear to you. So gravitational constant G is nothing but the force of gravity or attractive force acting between two bodies of unit masses, unit kg masses, and separated by unit meter distance from center to center. I hope that is clear to you, right? So gravitational constant or universal gravitational constant having magnitude 6.67 into 10 to the power minus 11 Newton meter square per kg square is nothing but the force or gravitational force acting between two unit masses bodies separated by unit meter distance from center to center, right? Now, if this is the force existing between any two bodies, so any two bodies, when we say, we can say that the bodies may be terrestrial or celestial, isn't it? So if we consider any celestial body or any body on the terrestrial, that is any object or human beings lying on the surface of the earth, so these are the reason, or we can say this is the reason, this force is the reason why all objects are attached on the surface of the earth, why we don't leave the surface of the earth, okay. Means we don't leave the earth naturally, we apply external force in order to leave the surface of the earth. Then why do we lie on the surface of the earth? Because of this force, okay. Why do the planets revolve around the sun? Because of this force. Why does the earth or the moon revolve around the earth? Because of this force. So all the bodies in this universe, each and every object in this universe is governed by this force, and that force acts on that particular, on each and every body at each and every time, I hope that is clear to you, right? So let us see one example over here. So as you can see in the picture over here, there are two objects, one is our earth and our moon, right, over here, and the masses are m1 and m2. Now the separation, the distance of separation between the two is considered to be r, masses m1 and m2, right. So what is the force of gravity between the two, that is earth and the moon, or what is the force of attraction between the earth and the moon that keeps the moon on a particular orbit, right, that keeps the moon on the particular orbit revolving around the earth? That is the force F equals to G m1 m2 upon r square, right. So G over here is nothing but universal gravitational constant, which is valid or which is same for every object okay, for every object in this universe. That's why it is called as universal gravitational constant. So F equals to G m1 upon m1 into m2 upon r square is the gravitational force or attractive force or force of attraction existing between any two bodies in this universe. So in our example, we considered Earth and the Moon. So Earth and Moon, the force existing between them is given by G m1 m2 upon r square. And remember one thing, this force, that is G m1 m2 upon r square, is exerted on Moon by the Earth as well as exerted on Earth by the Moon. Therefore, we can say this is a force existing between two bodies, that is Earth and Moon. So here is the thing, as you can see. So as I said that this force would be existing. When I say existing, I mean that the force would be exerted by body 1 on body 2, as well as that same force would be exerted on body 2 by body 1, right. So body 1 exerted by, now as you can see, cut. Now as you can see, as I already mentioned, that the force existing, when I say existing, it means one body would be exerting on the other as well as the second body would be exerting on the first one. So over here, if I consider Earth as body 1 and Moon as body 2, the force on body 1 due to body 2 is F1 over here, as you can see, because the Moon is pulling the Earth, by force F1, as well as Earth is pulling the Moon by force F2, right. So if they are separated by distance r, that is center to center distance, and the masses of the respective Earth and Moon are m1 and m2, right. So the force of gravity or attractive force is given by F equals to G m1 m2 by r square, isn't it? G m1 m2 by r square. So over here, this is the force existing, but I said that when I say force existing, it means body 1, that is force on Earth due to Moon, equals to force on Moon due to Earth, both are same, that is G m1 m2 upon r square, right. I hope that is clear to you. Now as you can see the question over here, the distance of the centers of Moon and Earth is d. The mass of Earth is 81 times the mass of the Moon. At what distance from the center of the Earth the gravitational force will be 0? Now in order to find out the gravitational force, we need to keep one object or one body at that particular distance, okay. So suppose over here, as we have already seen, the force due to gravity is given as G m1 m2 upon r square, isn't it, upon r square. Now suppose this is Earth and this is the Moon. Suppose this is Earth, this is Moon, okay. Now this is center to center distance and that distance is given as d, okay. Now in the question they have asked, at what distance from the center of the Earth the gravitational force will be 0. So let us say this is the point, okay, and that is at distance x, from the center of the Earth. At this point, if I keep another body of mass small m, the force on it must be 0. Therefore, we can say the gravitational force will be 0 at that particular point, right. So what is the force due to gravity? Now force due to gravity would be due to Earth also, and then since force of gravity due to Earth, and this is the direction of force due to gravity, force due to gravity of the Moon. So force due to gravity of the Earth and force due to gravity of the Moon, both will be acting opposite, because force due to gravity or gravitational force is attractive force, right. So if both these two forces are in opposite direction, they must cancel each other. So that is balanced force condition, okay, balanced force condition. Then only we can say the gravitational force will be 0 at this particular mass, at this particular point, which is the distance x from the Earth. So what will be the distance from the Moon? It will be d minus x, isn't it, d minus x. So let us see, if F net or net gravitational force, Fg net gravitational force is 0, it means what? It means this force balances this force, isn't it? Both are equal in magnitude, opposite in direction. So balanced force condition. Therefore, let us write, if Fg net is 0, therefore Fg due to Earth will be equal to Fg due to moon, that is force due to gravity of earth is equals to force due to gravity of moon. So what can we write from here? We can write force due to gravity of earth, that is G mass of earth, okay, mass of earth, and mass of the object which is placed at this particular point upon x square must be equal to G mass of moon. Now mass of moon, as you can see in the question it is given, mass of earth is 81 times the mass of moon. So we can write mass of moon as mass of earth upon 81 into mass of the object upon x or d minus x whole square. Can we write that? Of course we can. So what do we have finally from here? What do we have? GM gets cancelled, mm gets cancelled. So what do we have over here? X square equals to 81 d minus x whole square, isn't it? X square equals to 81 d minus x whole square. Do we have that? Yes, of course we have. So if we square both in sides, what do we get? X equals to 9 d minus x, isn't it? So from here if we simplify this, what do we get? 10x equals to 9d. So x equals to 9d upon 10. So this is our distance from the center of the earth at which the net gravitational force is 0. I hope you understood that, right? So that was all about this question. Now let us see one more question. The centripetal force acting on a satellite orbiting around the earth and the gravitational force of earth acting on the satellite both equal F. The net force on the satellite is, now this is the earth suppose, okay, and this is the orbit around which the satellite keeps on revolving, okay. This is earth and suppose this is our satellite, okay. This is our satellite S which keeps on revolving around the earth, right. So they are saying the centripetal force acting on the satellite, centripetal force means towards the center, we know that is mv square by r. So let us write Fc, centripetal force. So Fc is nothing but mv square by r, that is centripetal force which we have already seen, right, where r is the radius of the orbit. And the gravitational force of earth acting on this satellite both equal. So gravitational force Fg, that is Gm capital M, let us write capital M, that is mass of earth, okay, mass of earth, okay, and into mass of the satellite small m upon r square, clear, okay. Now let me tell you one thing in this question. The gravitational force acting on the satellite due to the earth is the force which provides the necessary centripetal force, okay. So let us note that, okay, as an important point, okay. The gravitational force, the gravitational force provides the necessary centripetal force. Centripetal force is nothing but center seeking force which we have already discussed, right. The gravitational force provides the necessary centripetal force. So over here the force due to gravity or the gravitational force is equal to the centripetal force which is of the satellite revolving around the earth. So over here both the forces are same, only the name are different, okay, only the names are different, that is the gravitational force acting on the satellite due to the earth is actually the centripetal force, okay. So what can we say? The net force on the satellite is F, the net force on the satellite is F. Don't get confused over here, okay, don't get confused, because the gravitational force is only the one which is providing the centripetal force. If there is no gravitational force, there won't be any centripetal force. I hope that is clear. So over here the net force acting on the satellite is F, okay, that is F. Now let us see the last question based on universal law of gravitation, that is F equals to G m1 m2 upon r square. Now as you can see the question, two particles of equal masses go around a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle is. Now let me tell you, if the two particles are moving on a circular track, okay, round and round, and both the particles will attract each other, we know, because every object on this universe or in this universe, they attract each other, and that force is nothing but force due to gravity, that is given by G m1 m2 upon r square, isn't it? So over here the radius of this circle or orbit, I mean circular track, is r. Clear? So what is the force due to gravity or mutual gravitational force or attraction? So in this case it will be G m square upon 2r whole square, because the total distance between them, they will be on the circular track at any instant or at any point. The distance between the two masses would be always 2r, because 2r is the diameter of the circle. So that's why 2r whole square. So that is basically nothing but G m square upon 4r square, right? So this is the gravitational attraction or mutual gravitational attraction between the particles. Now what is the centripetal force over here? Centripetal force Fc would be nothing but mv square by r, where, because capital R is the radius of the circular path. Okay. Now this centripetal force to each masses, this mass as well as this mass, is provided by this gravitational force, isn't it? So let us see what is that. So Fc equals to Fg, so mv square by r equals to Gm square upon 4r square. So this is the centripetal force, that is nothing but gravitational force. So from here, if we simplify this, what do we get? M gets cancelled, 1 r gets cancelled, isn't it? So v square is nothing but Gm upon 4r, Gm upon 4r. So what do we have from here? V would be, taking square root on both hand sides, okay, we get under root Gm by 4r. Under root Gm by 4r is the speed of each particle which are going around on a circle of radius r under the action of the mutual gravitational force. Okay. So that was all about our universal law of gravitation. Thank you.